Yeah, experience so far with the ELS is good, I think, but there's a steep learning curve for me. I've never been into CNC before, and this is like semi-CNC, at least from the point of view that everything is controlled when you do this after you've made the setup. ELS in this form, as I said, uses the screw, of course, or screws for positioning, so you need them to be accurate. And little bit smaller display, of course, than you would want to have, so it's not a DRO big display, but still I've now used it a little bit and I think that's okay. When it comes to these different operations like threading and internal threading, also haven't tried it more than once actually, but external threading, I made a few examples in brass, in aluminium, and now in steel. It performed as it should. But the new ELS 3 has X and Z zeros, so that you can de-energize the steppers. I'll have to put that on this ELS 2 so that I can use the hand wheels. You have this slight resistance, which at least on this axis, I tend to think that if I don't need to use the x-axis for some, let's say, advanced operations, I'll just take out the two screws, and then you're way back to without this resistance also. You can modify with the ELS the settings so that you can move fast and slow. I mean, all these parameters can be set rather freely, but I would recommend so that you have a slow feed at least, so you can use this for finish turning. The program here, for instance, for threading is excellent. You have to play a little bit with, I think, your machine if you want to put such a system on your machine with regards to how much in-feed you can use. I learned that it's like the 12 passes suggested is probably on the low side when it comes to a normal thread in steel, so I'd rather do 20. And I mean, it's automatic anyway. You set your zero position and you just start from anywhere. It finds the zero position again, and then if you set that a bit on the right side of the thread, if you thread in normal from right to left, and this gives the motors a little bit acceleration distance, and then if you set your in position exactly, it starts the first thread, stops in the recess, okay, pulls out, back again, and it's 20 turn, takes no time. And the Myford with regards to threading is really way ahead of, I think, just the belt driven machines where you have the back gearing here, so you can really do powerful turning. Cover is of course absolutely necessary so that you don't get swarf inside. On this side I didn't build the cover yet because I wanted really to retain this as much as possible as original. As you can see now, I have a tooth belt, which is okay. The motor is then sticking out so far, as it also turns out that I think a one-to-one coupling is needed. I'd like to have the motor in line with the lead screw. Same here, all are not so necessary, but at least one-to-one is imperative. I have now just used what I had, so this is 1-to-1.6 and this is 1-to-1.92, so rather awkward. It is possible to plug it in anyhow and find out and do, but it's better with 1-to-1 as suggested by the manufacturer. And having an inline motor here means that the motor will stick out a little bit further here, so I have to modify this. I mean, drill a hole. It should be plain and simple, but there is room for that, and then I can mount it with the covers and everything on. So could I recommend this system on the Myford? Yes, absolutely. The Myford is a small weight, really, so you do yourself a favor trying to tidy up, means snug up axis, not in use when turning, everything like that. Having a fresh set of screws helps, of course, when you use them like you do now on this system for positioning. I made this special long 2mm lead screw here, which also then made, so to speak, you can use the Myford original dials, the same here actually also. Parting off is no problem. That's of course not down to the ELS, that's more or less down to that this is now rigid, scraped, and everything fits really well, but can't see any problem. The main thing is really good lubrication, I think, for me, and of course the tool sharp and at center height. So for most, I think, as for me, the ability to replace the gearing and the work to change gears, I mean everything associated with that, with this automatic threading possibility and also with feed, then was the decision maker. So having said so, you can easily then just put on the banjo again with the gearing, of course, so everything intact. You have the possibility to just go back and forth, really, because I haven't done anything to the lead screw itself nor the half nuts. So the addition of the let's say the cross feed axis, control of that also is nice, because you can then make long tapers and very easily then of course control everything, and also the threading. But you can, even without that, thread, just so that you have to do it semi-automatic, so that you start, goes to the relief, you have to pull out again, and then back, and then restart. So it's convenient to have everything controlled, of course. Overall, very pleased with the ELS. And then I'll show you some examples of facing, threading, parting, and the normal turning, using the ELS, of course, and the setup of the functions, so you can see how this is done. And there is a lot more that I haven't learned yet, and there's a lot more training. This is, I mean, the learning curve is steep, and I'm still a beginner on this, newbie, so a little bit like intimidating, but when you keep it at this level, I mean, the worst thing you can do is really break a tip of the tool, which I have done, run into the tailstock, which I have done. I haven't run into the truck yet. I expect that to be the next, I guess. And some slippage of the belt, not the belt really, but the set screws on the axle here, the shaft of the motor, happened a couple of times. That is down not to, that's more down to the installation, really. Failure to set correct parameters, of course, yeah. So too deep in feed on the threading, which just on this machine just stalls the motor. Not biggie, really. I've seen a lot of these CNC crashes, and they are a lot more serious. So some examples.